So, hello everyone. Very nice presentation, Seth. Thank you for that. That was awesome. And definitely I agree with a lot of things. Even if you'll see in my presentation, people call it as DevOps engineers or DevOps. I think it's really hard to kind of agree with people and to say, okay, this means this, and then everyone agrees. But yeah, definitely a few words about myself. So I started out very long time ago as an Android developer, and basically I built up from there. I started developing apps. Then I realized that you can't do a lot without a backend, like a web backend for those apps. So then slowly I started moving in the space of being a Java backend developer, a web developer in Java, which I spent a few years doing. And then slowly I started automating things with the CI and CDs that we had, and putting jobs in place, creating the infrastructure and writing code at the same time. So I really enjoyed it. So I switched to that, I think around 8 years ago, maybe. And since then, I've been, worked in various companies, from startups to very large companies as a consultant, mostly, just helping them out to get up to speed with everything. So a few of the projects that I did that I'm going to talk today about were at Hive, which is dealing with IoT and devices in people's homes, like basically contact sensors, cameras, and thermostats and things like that. And yeah, right now and at Hive, I was a part of the research and development division. Basically, we were a bunch of, I would say, engineers, but operations, development, and business analysts, data scientists, and yeah, we were trying. We collected from the devices in order to spike up new products for our users. And yeah, right now I'm working at Toyota. So Toyota Connected, it's mostly moving up from IoT devices in the house to cars. Everything is quite interesting. I think it's a very interesting world because you have a lot of services. So working in R&D, usually you don't just hit a few services, but you work with a wide variety of those, and you kind of figure out the problems are more obvious, let's say, at least in my opinion. So yeah, today I want to talk about, and I want to show you some things around mostly processes and what we did, but I'll share some diagrams as well, which I can, and we can drill down. But basically, I had to cut a bit. This was a longer presentation, so I had to cut it a bit. Mostly, I want to talk about the advantages of self-service infrastructure and how we did it, and maybe you can take something from it and figure out how it's going to, if it's going to be useful for you. So this is, I think right now it should be a historical slide, but I think some companies still do it. And basically is how I've seen that things used to work, and from the point of a developer, right? So you always kind of, you need something, then someone needs to approve the budget, like you need a VM, and someone needs to install and configure the things in it. Then someone needs to free up, obviously. And then after the configuration is implemented, only at the end you see, okay, is it working for me? Is it not working? I got access to something. Right? And as a thing, operations teams always have an incentive to be risk adverse, right? And developers on the other side have an incentive to get the job done faster, better, easier, and step outside of the box to do if needed. So I think those are, let's say, the two directions where people usually tend to go, and it's this is slow and potentially expensive for the business, right? What I want to show you a bit about is the self-service model. So basically, this is a strategy to allow developers and users of your infrastructure or the architecture that you have to basically provision that infrastructure by themselves without the need of operations or sysadmins or DevOps engineers or however you want to call it, but in a flexible and secure way. And what I mean by that, and the reason I'll show in a few minutes, but basically the reasons for that is mostly reduces risk and cost, and that means reducing waiting time for the developers, providing a single, oh, I forgot to say my time. Provide a single workflow to secure, govern, and audit, regardless of who provisions, right? And removing manual error-prone processes in provisioning infrastructure. So this is at least one of the advantages that I've seen here. It encourages reusability and experimentation. So basically, you can write modules once, and then you can iterate upon them and reuse them as many times as needed. It also facilitates experimentation within acceptable, well-defined limits. So basically what I mean by this is that developers can now use various existing modules to test ideas fast. So if they want to play with a piece of technology that there is already a module created for that within the company, then that's way faster than waiting for someone to do everything from scratch. So basically having reusable pieces that you can give people to use. Another of the advantages is that implement standards and best practices, like writing those modules in the background, it kind of gives you the freedom to, in the implementation, to decide together with the business and with what to use for governance. For example, standard sets of tags that are agreed for reporting or security or cost or other reasons, and it's very, very easy to build automation around well-defined standards and conventions. Right? It's something it's way easier than if you diverge. So it kind of gives you some of those options. And I'm going to talk a bit more about building the data lake because that's what we use as and a bit less about Kubernetes. I'll just mention it really fast. But basically what happened is we use Kubernetes clusters to facilitate experimentation within our R&D team, so people can easily deploy things in there. People can, irrelevant of the technology, so you just deploy various Docker containers, and most of the things that we have were auto-scaling, which means that our infrastructure grew and shrank dynamically for Kubernetes based on the workloads that was running at the time. So it was actually quite cost efficient as well. But building a data lake, and that was one of the reasons. You have a lot of data, telemetry data coming in from all those devices sitting everywhere. And basically you need to somehow easily manage that and secure it and expose it and provide governance around that data. And this is exactly what we did. So I'll show you a few diagrams in a bit, but basically how we were thinking about our data lake implementation, we were thinking in terms of an ingestion layer. So for example, I'll show the diagram, but we have an ingestion part where you land the data into the lake, into the infrastructure and architecture that you own. Then you have a cataloging process in which you catalog the existing data, extract the metadata to actually figure out what is in there. Ideally, this would be automated and it wouldn't necessarily require user input. It would be able to adapt itself. And we have the concept of curated data sets. And basically that is any kind of data that we expose either to our internal teams or potentially externally to our partners, right? So, and how we are getting those curated data sets is by actually running ETL jobs to kind of convert that raw data that we land into some kind of data that people can or want to use more. And everything that we built around this, and you'll see next, is actually under the self-service model. I think one of the main reasons why this happened is like we identified a few issues. So for example, we have a really, really good team of operations engineers, really, really good team of infrastructure engineers, let's put it like that, which actually dealt with the creation of all of this. But before we learned a few lessons from the project that we did, and one of them was that you need to have a good balance between security and usability. And what I mean by that is you end up, after you implemented some things, and if you don't manage to automate everything in the time that you have in terms of granting permissions or security, things like that, and if you want to keep very, very granular permissions on some things, then you end up in a place where you need to do common tasks just because you need to automate them better. But it's like, can I get access to this or can I get access to that? And people's time can actually be used better. So this is kind of the concept that I was talking about. Here you can see all the 3 layers. So if we consider this our data ingestion and landing mechanism, this would be the first bit. Then we have the cataloging bit, which is here, and here it's the curation and the expose part. And basically what we are doing here is we are using various AWS services within our accounts. We are using AWS for this mostly. And we are using things like Terraform, Atlantis to kind of automate those workflows, and I'll show that in a bit. We are using AWS KMSs, we are using EMR clusters, we are using AWS Glue, we are using Kinesis Firehose, S3 buckets, and Lambdas, and a lot of other technologies. And basically, if what happened is everyone started to do things, and then that easily diverged in a way. So you can see all the layers here that I mentioned before, but basically Terraform, I think everyone knows, is an open source tool that defines infrastructure as code and can be shared amongst team members, edited, reviewed, and versioned. Atlantis is an open source tool that enables Terraform pull request automation for GitHub. So it works with GitLab and Bitbucket as well. You can think about it as the glue between GitHub and Terraform in our case. And a Terraform module is basically a container for multiple resources that you use together, right? So you can think about it as those are used to create lightweight abstractions. So you can describe your infrastructure in terms of its architecture rather than directly in terms of physical objects, which I think it's really good. A few words maybe here around how we used to develop those modules. So, for example, initially when we need to get something done, you would have, let's say, a developer and infrastructure engineer working together in creating resources manually in AWS to try to figure out everything, the configuration, what works for them to do a Spike proof of concept. As soon as that is done and both of them are happy, which kind of helps both of them to understand better the configuration, to communicate, to kind of see what's going on. And once that happens and they're happy with that, is in the background, the infrastructure engineer would actually start creating and rolling out a Terraform module for the set of resources that we want to use together. And then basically replace all the manually created infrastructure with these new modules and things we created. So one of the biggest advantages, I think, in the self-service world and using the Terraform modules is basically developers don't need to know Terraform, which is it has a learning curve attached to it, and it's not so easy for someone to, let's say, pick up from scratch in terms of best practices, organizing everything and troubleshooting. So what we did is by creating those modules, you actually abstract things for them and you give them something that they can input some configuration into, and they will know what it will create in the backend. Right? Then that's one of them. Modules can be iterated on and have their own release cycle. So you can think about having, for example, a module, which is, in our case, this is a module. So for each data source that we landed in, let's say we have a Kinesis stream, a Kinesis Firehose, an S3 bucket, and a KMS key, right? So we package all of those as one of the modules. So if you zoom in into our ingestion layer, you might see something like this. So for each of these components, we have a module which lives in its own GitHub registry and has its own release cycle. So you can think about, you can iterate on them, you can tag them, you can release them. Uh, we also have one for S3, one for KMS, Kinesis Streams, and Kinesis Fireholes. Those, by using composition, we kind of create bigger modules in it, which in this case we call Kinesis Firehose in ingestion. So whenever someone would deploy something like this, it would create all of this in the background. And yeah, this were developed together by people. So initially configuration was put in place by both, and then a module was created and everything was automated. I also wanted to show the flow in how Atlantis fits in everything and how it hooks up together to kind of create this nice automation and audit log. So I told you that you can think about Atlantis as the glue between, let's say, GitHub and Terraform in order to create infrastructure. So basically what happens is we have all these modules available, right? You wanted people to start using them. So we wanted everyone to be able to use the modules. The user can be an engineer, a developer that is working on a project, and he just needs some quick resources, right? So we have the repository in GitHub, and how the flow works is on our infrastructure repository. A user, which can be a developer, an engineer, an infrastructure engineer, can create a pull request on the infrastructure repository. Atlantis picks up that pull request, and basically you can run things like plan and apply. So Atlantis pulls the code, does a plan to see what changes will be made on the infrastructure. That's the next step. Then the output of that plan is getting posted back to the PR in GitHub. And there needs to be at least one reviewer that approves that PR. So someone, usually an infrastructure engineer, or can approve that and review that. And basically what would happen once that's done, someone can just apply it and deploy infrastructure straight from GitHub. So you can just go in the GitHub comments and do Atlantis apply. And what would happen there is all the infrastructure will get created, and then the output of that gets attached back into the PR, and then the PR can get closed, right? So what this gives you, it gives you the advantage of not only having people and making it very easy for people to use those things. So in terms of engineers, if I want to deploy another ingestion stream, I just go to a GitHub repo, create a pull request, and I have my new ingestion layer for an experiment that I need to do. It's easy, and I didn't need to wait at all. It took 2 minutes. And also the advantage is that all those modules, and you'll see in a bit. So for example, this is exactly how one of our reusable modules looks. I just deleted a few things in there, but this is our Kinesis Firehose ingestion layer. You can see that it has a tag. So basically each modules are versioned individually in GitHub by having tags, and then we can refer those from here. And it's basically all the parameters that bubble up are the parameters that go and feed the other modules that compose this one. And you can see, for example, if I would be an engineer, like a developer that doesn't know Terraform, I can understand what this means if I log in. Everything is quite descriptive, and yeah, everything is really easy to use. So as I think Seb mentioned before, I do think that DevOps is a lot about streamlining things, about automating, about working together, communicating, experimenting, and be able to do all those things. And for us, I think what we did with the modules and having everything provisioned self-service and having that audit log in GitHub with what everyone changed, it helped us a lot in terms of achieving that automation and having everyone happy and being able to deliver faster. Do I still have time? I forgot to start my timer.
Keep going, we're good.
Okay, cool. Yeah, so I think mostly, I think I will have it a bit shorter because I think I might have removed more slides, but why self-service is I think if you use Terraform, if you use an automated way of creating your infrastructure, moving into a self-service model with most of the things that you have will kind of reduce friction and will help people work better together. In terms of it's really easy. You can have things that you need right there and people's time. So for example, you don't have people doing boring things, things that can be automated or can be thought about in a different way. And people spend time doing more interesting things. So for example, I want to create new modules. I want to look into automating this bit or automating something, another part of your infrastructure. It's been a really, really good experience, but it is also a kind of culture change because I think it needs to come down from the top of the company in terms of having the support to kind of do all this and deliver all this. We needed to really sell it to be able to do it. Yeah, I think that was everything that was it from my side, but I do have some time for questions, I think. So.
Excellent. Thank you very much, Adrian. Thank you.
Cheers, Adrian. Thank you.
Woo! Okay, so, oh wow. Since I last looked, there's been 4 more questions coming. So which ones am I going to pick? Okay, so if you've got a little time for some questions, Adrian, then hopefully we can get through some of these. So one from Christoph. Hi, Christoph, all the way from Bulgaria. No, sorry, you're in London, aren't you? Have you considered Snowflake DB to query S3 data directly?
No, not right now. How we are doing, how we were doing that before was actually by using Athena. It was quite easy to query that data.
Okay, cool. Thank you. So next question from Phil. In your experience, what's been the biggest challenge in implementing the self-serve model? You mentioned the positives, but what are the pitfalls and stresses around real-world implementation that you had? Sorry, that sounds like a very long answer could be coming here.
I think one of the challenges that we faced is, especially if you start a project from scratch, it might take a while, until people can actually see the benefit of it. So initially you need to put in the groundwork to work on those modules, to create them, to kind of automate everything, right? You can do it on the side. How we did it is people create things manually to kind of unblock the flow of work. That's one of the models that we ended up with that worked really well. And then you automate in the background, right? But it needs a bit of discipline in terms of actually replacing what you have with automation, because when people usually say this is just a workaround or a temporary solution, usually it's not in 90% of the cases.
Fair enough. Good answer. Thank you. So one more from Emrilla, who asks, how can we prevent someone changing something manually when we use Terraform in our architecture?
Don't give AWS console access. Maybe you can just use things, but it gets a bit difficult. I think it's mostly also, you wouldn't need to block that necessarily. I think it's a problem of culture and how you agree of working together. So for example, in this case, what we agreed, we have a repository describing one of our data lakes where we used all those modules that I showed that we created. And the thing is, in there, all the engineers have access, but we agreed that there will be no standard Terraform code there unless we really need it, like low-level code. It will be just models usage. So there is this kind of section or this side of people agreeing on standards, conventions, and how to work together.
Okay, cool, good. Can you cope with one more question?
Yeah.
Yeah. Where's it gone? It's moved again. There it is. This is from Mark. Not that Mark. How do you figure out what should be in one Terraform module and what should be in another module to ensure reusability?
Yes, I think it's experimenting, like, and actually doing it, how you kind of learn after a while. After you do it, you kind of get a feel of what should go where, and there is also change. So the reason why we have that set up is, for example, each of our modules are versioned and we can iterate on them. So we can remove modules, we can change them at any time. And also one of the biggest advantages, which I forgot to mention for versioning, is that you don't need to change all the, so let's say I'm using that ingestion model for 10 data sources. I don't need to roll out the changes. I have an update for my ingestion model. I just updated for one data source. I just changed the version and I can roll that out, see how it goes, and then goes out. I do have to mention one of the downsides of doing this, which I think I forgot to put in there. It was mostly related of there needs to be a balance between how small your modules are. Like basically, if you have a lot of small modules and you need to implement a change in one of the base modules, like a version bump, you need to bubble it up all the way to top, right? So you need to update all of those as well.
Brilliant. Okay. Your interrogation is now over, Adrian. Thank you so much. Thank you very much.